Hello everyone, I am Professor Mutkule PR. Today we are going to discuss a new topic of our subject, that is artificial intelligence and robotic state space search. So what is meant by state space search? In the artificial intelligence, the most important application of artificial intelligence is problem solving. So what happen in problem solving? We have given one problem and we have to solve that problem with a respect to different states. Okay, so we are considering different states in order to reach the solution of the problem. That is also called as the final state of the problem. So this is nothing but your state space search. So what is motivation behind the state space search? Many analytical problems can be solved by searching through a space of possible states. That means what? Here spaces mean what? There are different states we have given in our problem, or we have given with a different states in order to reach our final goal or final states. So starting from an initial state, we try to reach a goal. That is, first we start from the initial node, or first we start from the initial state, then we move towards the second state, third state, fourth state, and lastly the goal state. Okay, so in between these initial state and goal state, we have to travel with different state. Okay, sequence of actions leading from initial to goal state is a solution to the problem. As I have already discussed that these states in between the starting state and ending state are the sequence of steps. Okay, that means step 1, step 2, step 3. Okay, by using these steps or these states, we can reach to our goal easily. So what is the issue? The large number of states and the many choices to make in each state. So during the problem solving, there are thousands, or we can say millions of possible states to reach the particular goal. So among that particular states, we have to select the optimal states, okay, or optimal search in order to reach our goal. That means we can reach our goal in a minimum time. So what is next? Search must be performed in a systematic manner. That means we cannot directly jump to the further states. Okay, we have to sequentially go through the one by one states. That is, first, that is initial state, then state number 1, state numbers 2. We can't go directly to the state number from state number 1 to state number 4. Okay, we have to travel sequentially from state number 1, state number 2, state number 3, etc. So typical problems in the artificial intelligence, as I have discussed that the problem solving is the main application of artificial intelligence. So what are the example here? Tower of Hanoi, then 8 puzzle problem, then tic-tac-toe game, okay, then 8 cubic problem. So these are the example of problem in artificial intelligence. Another example is finding a particular destination using your GPS, okay, mobile GPS. So what is the formal description of the problem? So problem can be given with the help of the tuple as represented here. So here S is the state, okay, S0 is the initial state, A means particular action on that state, then action S, that is action on particular state, then result, that means final result. That means what? We have reached our goal or we have reached our state. Then cost means what? Cost means the time to reach to the particular goal, okay, time, or we can say that the optimal path to reach our goal. Okay, so let's take example of the 8 puzzle problem. So in 8 puzzle problem, 3 by 3 grid is given with 8 sliding tiles and 1 blank. So all you have well familiar about 8 puzzle problem as given here. So in 8 puzzle problem, what are the possible states? That is, you can move upward, you can move downward, you can move either right side, or you can move either left side. So these are the 4 possible states, or 4 possible, we can say that the state of this particular problem. So in initial state, some of the configuration of the tiles are given here. Okay, so if you want to move this blank side to the upward direction, then what will be the state? State will be the upward. Okay, you can move this blank side to the upward direction, to the downward direction, to the right side, and to the left side also. So slide tiles to reach the goal. Okay, as I have discussed, now you can slide the blank slide to the left side or to the right side. Okay, and one more thing, this is your, what we can say, final state or goal state. So while solving the problem of this 8 puzzle, I have discussed that what are the possible state, that is up, upward, left side, downside, and right side. Okay, so if you consider the upward side, then the next state will be like this. If you consider the left side, then the state will be like this. Same for the down state and the right side state. Okay, so if you move forward from upward state, the possible set of next state are, you can move either left side or you can either move right side. Okay, that means if you consider the blank slide here, you can move this blank slide to the left side or to the right side or to the down side. Okay, so there are many possible action you can take here, and by considering these all set of action, it will form branches. Okay, so these are, first one we can consider this as a parent node, then these are the child node, and for this child node, these are again, we can say, subchilds. Okay, so like this we form a hierarchical tree structure, and using this tree structure we can find a optimal or the minimal solution to reach our goal. That means how we can complete or how we can reach to our goal like this with a minimum time or with a minimum possible action. So what are the properties of a problem? Yes means, as we have discussed, that yes means number of state. Here B means what? B is the branching factor. Okay, branching factor means what? How many branches you have formed, or how many branches your problem have formed during the problem solving. Next is what? Depth of the optimal solution. So these are the branches. Okay, and depth means what? Levels. Okay, so this is level 1, this is level 2, again level 3, level 4. Like this, the problem will the problem solving strategy will create the levels. Okay, understand? These are the branches, and from or we can consider the level as the depth. Okay, and M is the maximum depth of the search tree. That means how far will the level go downside while solving the problem. Okay, so generally In order to solve a particular problem using search strategy in artificial intelligence, big O of b raised to m will be its complexity. So here b means branching factor and m means maximum depth. Okay, m means maximum depth of that particular searching strategy. So these are the search algorithm, types of search algorithm: uninformed search and informed search. Uninformed search means what? You will go solving a problem without knowing the further state. Okay, like this is the example of uninformed search. You will go solving the problem, go and go again and again without any prior information. Okay, and how will you consider this, or how will you treat this? You will treat this up to the reaching of the goal. Okay, next is informed search. Informed search means what? Here one heuristic function or heuristic value is given, and using that heuristic value you will solve the particular problem to reach the our final goal. Okay, so types of uninformed search are depth first search, breadth first search, and uniform cost search. And informed search, greedy search, A star search, and graph search. So in our next lecture we will going to discuss the uninformed search and its type. Thank you.